Good afternoon. Thank you for coming to today's SETI Talk. Our guest speaker today is Michael Carroll, artist and author. Michael, for the last 30 years, has been drawing and painting space-themed pictures, and for the last 20 years has been writing nonfiction articles, popular science articles, and writing fiction stories. And he has recently published his first book, On the Shores of Titan's Farthest Sea. And there are actually, for those of you who are here today, there are copies of this book on a book table out front that you might purchase as you leave. And today Michael is here to tell us how to survive a methane monsoon. So let's welcome Michael.
Thanks, Matt. All right. Great to see you all here today. Thanks for coming. Titan is one of my favorite subjects. A few years ago, I did a nonfiction book called Living Among Giants about how humans would explore and settle the outer solar system beyond Mars. And when I was doing that, I had to do a lot of research about Titan, Saturn's largest moon, and it just intrigued me very much. So that led to the novel that we're talking about today. But first, let's talk about real things. Titan. By the way, the book is called On the Shores of Titan's Farthest Sea. The title frequently is done by committee, sadly. That's about 5 words too long, but that's okay. So in Denver, people often say that God must love the Broncos because he makes sunsets orange and blue. Well, if that's the case, he probably is interested in Titan as well. It's got these blue polar caps, hoods of methane gas, and this nice orange, dense, fluffy atmosphere. It's really a beautiful and elegant world in its own right. Here it is compared to the Earth. Titan is essentially a planet. It's about the size of the planet Mercury. It has lots and lots of atmosphere. Fascinating stuff going on under that fog. And before we explore those things, a little trivia. To do a novel about some place like Titan, you have to get a map, the very best map you can that's available. The maps are getting better and better and better as the Cassini mission clocks on and continues to map the surface of Titan. And so I took that map and put a bunch of landmarks on it that have to do with the plot of the book. And so I'm going to ask you this question, and the first person to get it right gets a copy of my working map. What 2 things fall from the skies of Titan? Yes, sir. Methane and Huygens probes. Okay. What 3 things? Good. Very good, though. Yes, I hadn't even thought of that. Yeah. Methane and solar. Yes, methane and hydrocarbons. Very good. There you go. He did, yeah. You guys can split it right down the anti-solar point there. All right, very good. So those 2 things are going to figure in what the place is like. If we look at the atmospheres of the terrestrial planets, the little worlds that have a nice solid surface to stand on and a fairly thin atmosphere, most of the terrestrials, the main planets, the 4 of them, huddle around the sun: Mercury, Venus, Earth, and Mars. But if we take a look around at atmospheres, let's take a look. First of all, the Earth has 1 bar. That's how the Earth has more than 1 bar, but 1 bar of atmosphere, and that's 14.7 psi at about here, sea level. Okay, so every square inch on your body is enduring about 14.5 pounds of pressure. So Earth has 1 bar. The moon has virtually nothing. It's essentially a vacuum, okay? But Europa out at Jupiter has something called an exosphere. It's barely hanging on there. A few things, a few little particles little atoms there. But Mars is much more like a real atmosphere. It's got the air pressure of Earth at about 100,000 feet. So there's not much to breathe. It's all carbon dioxide. Then comes the Earth. You know what that's like. And then, surprisingly, is Titan. Titan has 1.5 times as much air pressure at the surface as the Earth does. It's got a really formidable, interesting, dynamic atmosphere. And then, of course, Venus comes in at about 90 times what we have, and it's not a fun place for a picnic. But Titan's atmosphere is fascinating. Titan has more atmosphere than a fancy Italian restaurant. And under that atmosphere, there are strange things going on. We knew this for a long time. Carl Sagan and some of his colleagues came up with some calculations that said that the surface of Titan is at the triple point of methane. Now, the Earth is at the triple point of water. That means you can have ice and liquid and vapor. And they thought that Titan was just at about that spot, okay? So they thought maybe there were big oceans of methane on the surface of Titan. When we got Hubble up there, it began to see through some of that murk that Voyager was not able to penetrate. And sure enough, we saw that there were these dark places on the surface moving back and forth. Well, moving one way, of course. What were these? Maybe these were these bizarre alien seas. So, time would tell. We couldn't tell from Hubble. Now, to give you a little feel for what it's really like on the surface of Titan, let me just read you a few paragraphs from my little novel. So we have a description. So just close your eyes, put yourself in this alien environment. If you've had lunch already, don't close your eyes because you'll go right out. The dawn struggled to claw its way through the orange gloom with little success. Even on the brightest of Titan's days, dawn hung on tenaciously until mid-morning. Sometimes you could see a faint glow from Saturn beyond the mist, always amorphous. But not today, not in this soup. It was all so ironic. It had only been a few years since Kevin Nordsmith had taken the job in San Diego to get away from those lousy Washington, D.C. winters with all that ice. And now he was living on an ice ball. And cold? Nation's capital had nothing to compare. Just my luck ending up in a place like this, he thought, as the sweat trickled from his forehead into his left eye. Nordsmith had been slogging his way across methane bogs all morning, taking care to miss the subtle hollows filled with quicksand. The hike to the cave was not an easy one. The methane drizzle only added to the challenge, but he had to get up there. He had suspected that he wasn't alone. And now that he knew it, the cave might be his only chance. A dark entrance stood at the top of a steep hill, gaping like a monster's maw. Scrambling up the loose scree, Nordsmith tried to concentrate on what he had seen, on what he wasn't supposed to see. He lunged into what he hoped was the safety of the cave, but as he turned around, they were out there on the plain below, and they'd seen where he was headed. He twisted back into the darkness, beaming his flashlight only sporadically, still hoping to lose them in the cavern. The walls were smooth. If he didn't know better, he could convince himself that the place was made of stone. But the ground and mountains and boulders of Titan were water ice, frozen to the consistency of granite. The path looked flat and straight for another 10 meters. He shut off his light and made his way slowly through the darkness. Suddenly, light flooded his surroundings, casting wild spikes of surreal shadows, the walls glistening like diamonds. He turned around. 3 hulking figures loomed behind him, wearing pressure suits very different from his own. One of them held up 3 fingers. He switched the receiver to the frequency. That's all you get. But hopefully that gives you a feeling of what it would be like on this magical, wonderful world, just half a solar system away. We know much of what we know today because of this school bus-sized probe that is in orbit around Saturn right now, Cassini, a spectacular mission that's been in orbit since 2007, is that right? 2004, thank you. It's been there a long time. It's done some spectacular, complex things, and one thing it did was it dropped off this probe designed by the European Space Agency, the wonderful Huygens, which made it to the surface and revolutionized our view of planetary atmospheres and what a strange moon could really be like. Now, I want to show you a 2-minute little video taken by the Huygens probe. Now, what you're going to be seeing is an assembly of all the pictures it took. This little probe had a very simple camera on it. It was a slit scan camera. It didn't have a scanner. The slit instead was mounted to the body of the probe, and it spun as it came down on this parachute, okay? So the outside edge of this image, all along here, that's going to be the horizon, okay? The nadir, the spot where you're going to hit, looking straight down, is right there in the middle. And all these things are different imaging devices, photopolarimeters, different kinds of camera systems that it turned on and off as it went down. And so every time one of those flashes, you'll hear a different chime, and you'll see the area that it covers. And so all these pictures will build up, and you will begin to see what Titan really looked like. Remember that before Huygens got here, this was terra incognita. We never had seen this world before, certainly not on a human scale. People were hoping that it would make it down to the surface and survive, but it wasn't really designed to do that. And so let's have a look at what this probe saw over the course of about 2.5 hours. This will not last that long. There it comes. Notice Mount Everest at the bottom. That's the height of Everest. Sun direction, this is how quickly the probe is spinning. And the picture is beginning to build up as the probe descends. Now notice too that the sky is very blue, it's very clear. We're up above most of that haze layer, okay, that soupy orange stuff. But as we get down, things will get much more foggy. Notice too that we dropped off our big parachute. We now are on a little one so that the probe can fall quickly through the atmosphere before the mothership, Cassini, is out of range. Cassini is the relay to the Earth, okay? It's the only direct link that the probe has. And so the probe's mission actually ended not because the probe died, but because Cassini was out of range. Now, there were some observatories here on Earth that actually were able to listen to the probe to very low data rates, even long after Cassini was gone. So it was a hardy little thing. Now notice, there's some things looming out of the fog, right there in the middle. The mountains you see are mountains of ice. There's no rock, probably, on the surface of Titan. It's all frozen water. It doesn't rain water. It rains methane, something that we heat our homes with, essentially. All right, we're coming through the fog. We're at about 33 kilometers up. And now watch for some Earth-like familiar forms. See what you see. That dark stuff is probably sand, ground up ice mixed with tholins, with these hydrocarbons that constantly rain from the sky. Notice the big mountain up on the, just to the upper left of center, and you'll begin to see some dendritic forms, some river forms, branching things. There are dendritic forms throughout nature, throughout many different scales, from trees to alveoli in the lungs. These are visible images, yes, visible light images. The data is essentially in black and white, but they have things like photopolarimeters that tell you what the background color is. So they then insert that in digitally. All right, so we are on our final descent here. We're at 10 kilometers, about 6 miles. Getting close, headed for that dark sandy spot. Notice that so far we have found no shopping malls. Almost there. Now, it was commanded to take lots of pictures more frequently the closer it got to the surface, because we really thought that the thing was not going to survive the impact on the surface. So now we get more and more detail as we come in. Almost there. And now we did survive, and it's still taking pictures out that little slot camera of this one spot. And it did it for a couple hours almost, essentially. It probably did it longer than that. As I say, the batteries had not given out by the time we lost contact. So a very dramatic and spectacular little mission. Do you notice anything about the rocks in the picture? They're worn smooth. What could do that? They don't look like moon rocks. There are weathering processes going on, and in fact, they look more like river rock, like they have been rolled in liquid. So it may be that Titan's methane does not come in gentle spring showers, but rather in sporadic monsoons, very, very dramatic cloud bursts. Because of the shape of these rocks, we can see that tells us a lot about erosional processes that are going on there. So the Earth has a nice water cycle. It rains water, turns into oceans, evaporates, turns into clouds, and rains again. And methane is what does that on Titan. There are standing bodies of methane in the north and one big one in the south. There are probably methane aquifers, methanifers, I'm not sure what you would call that, subsurface inventories of methane, and so those things do the same stuff. You can see this big methane storm brewing in the southern hemisphere there. Here, let's look at that again because it went so fast. Here we go. Cassini images using the visual and infrared mapping spectrometer. And so Cassini is made to look through the fog a bit. It can see general surface stuff like you see here. Kind of, you can see hints of canyons and craters and stuff, but to really, really get a good view, we have to somehow peer through all that murk. And Cassini has been doing that. They've been building maps. This was a little 2008 animation, and all those blank spots essentially have been filled in by now. But how do we look in detail at that surface? Every time, almost every time, the Cassini flies by, it turns this big radio antenna, which it communicates with Earth, it turns that down, and it uses it as radar to pierce those clouds and look at what's underneath. And so we get these long, skinny things, which they call noodles, and each of those noodles is several thousand miles long. And so let's take a look at one of them. Here we are at about the equator. Now we're moving up toward the pole, and we see some very, very alien-looking things, and also some somewhat familiar-looking things. There's some dark spots near the North Pole there, which we'll talk about. There are mountain chains, dark regions that were very, very mysterious for a long time. At first, researchers called those cat scratches because they had no idea what they were. We have seen wind-blown dust on the surface of Titan. Here is Mars on the right, Titan on the left, both about to scale. And you can see on Mars, you've got these wind tails that come out of the craters. Similar thing going on the surface of Titan, okay? So Titan's got wind, and it's got all these black cat scratches, which turn out to be sand dunes. People thought, okay, so on Earth we have rock, and rock gets ground up and blows around and turns into big sand dunes. But something different is happening on Titan. We not only have a methane cycle, but we have a hydrocarbon cycle. When the sun reacts with the methane in the atmosphere, this kind of soot rains out of the sky, snows out of the sky, and it banks in sand dunes. There are dunes in the Namib up above and Titan dunes down below, both at the same scale. So notice that we are having these longitudinal dunes on Titan, very, very much like what we would see on Earth, although they're probably black. Turns out that the dunes act as weather vanes, which is kind of handy. The wind blows in essentially one direction across the globe, and you can chart its direction by all these little arrows. Now, that big tidal wave of atmosphere that moves across this moon is called superrotation, and there is one other place in the solar system, one other planet that has this. Anybody know what it is? Venus, very good. You guys are too good. See, if I asked that at a bookstore signing, no one would know. But this is a good audience. Superrotation also happens on Venus. The air moves around, I believe, about every 4 days. Hurricane force winds on Venus. They're not that strong on Titan, but nevertheless, you get this big wave of atmosphere that moves across the planet. It's very, very different, much simpler weather than what we have here. Also looks like there are rivers, leftovers from that methane cycle, okay? These were some of the first hints we had that in fact it was still actively raining methane, or at least had done so in the recent past. Here are these mysterious dark blobs on the radar. They do not have the same return, the same bounce that the dry land does, because they are liquid methane. The first alien sea that we have ever seen in action. Some of them have big islands in them, and this is Maida Insula, a giant island in Kraken Mare, which is the largest methane sea. It's about the size of the Black Sea, really big. And if you look up here at that island, it's about like the big island of Hawaii, right there. Okay, so most of our action in our story takes place at that little X at Maida Science Outpost, which is on the nice tropical beach of Titan there. There's no palm trees, I don't think. But we get a lot of these weird little lakes. And they remind us of something that we have seen on Earth. Anyone here from Minnesota, Wisconsin? You seen lakes around there? No? No? What do those lakes look like?
Well, they're small and they're flat. There's a lot of them.
Right. There's a lot of them. And they look a lot like this, don't they? What is it that leaves behind lakes like this?
Glaciers.
Glaciers. These are called kettle lakes. And these are all over the place where the North American continent was glaciated, and the big sheet of ice stops, breaks up, leaves behind essentially icebergs, which melt and make these little kettle lakes. And Titan is full of these. So what does that tell us about the past on Titan? There may well have been glacial-like movements of ice, probably not water ice, possibly other stuff. But now that's one theory. There are several theories actually about the shape of these lakes. It may be that methane itself is eating away at the surface around it and just doing something like these kettle lakes. Again, it's an alien environment. We don't have all the answers, but we do have a lot of theories. So, what, you may ask, about volcanoes? I'm glad you asked. Are there cryovolcanoes, a very, very cold cryogenic volcanoes erupting on Titan today? This is very controversial. There are structures that are reminiscent of volcanic structures here. This is Tortula, the snail on Titan. It has spiral kind of shelves of ice moving out, just like you get spirals of lava moving out of a shield volcano. there's a lot of controversy about whether or not that's what that is, but Hautei-Arcus is more often pointed to as an example of likely cryovolcanism. It has some topography that's very reminiscent of lava flows here, and there seems to have been some changes. Watch very carefully. This is pretty subtle, but these images were taken by Cassini over the course of about a year or so. Notice the change in the surface. Something is happening down there, something active. It may be that these images were taken from slightly different angles. That may explain what's happening, but it may be that there are physical changes happening down on the surface. This is a painting I did for JPL of what Hautei-Arcus might look like. I used radar data in a Terrigen software package that gives you elevation. So the stuff down here is what looks suspiciously like lava flows. So you might get these kind of cool, misty Yellowstone-like things going on Titan itself. All that to say that this place is becoming a real world. We are putting names, markers on it. We are putting our imprint on these maps, where once we had to put Tharby dragons. Now we have places like Belet and Adiri and Xanadu, places that we can really grasp on a visceral level. And so it's fun to imagine what it would be like when humanity moves out into this bizarre planet-like moon out at Saturn, and we begin to explore and settle this place. This is a bit of that working map that you won, and you can see I had to insert some things like human outposts and stuff, along with cryovolcanic sites, because some of those may not be that, but it's fun to imagine that they are, especially for a plot point. And so we've got these great methane seas in the north. When methane sits around long enough and evaporates, what's left is ethane. And so there may be a mix, very much like on Earth we have salt and fresh water. On Titan there may be ethane versus methane. The ethane will tend to stay on the bottom, and the methane will evaporate. So you get some strange mixing in some of these big oceans, big seas up in the north. In my plot, I also talk a little bit about asteroid mining. This is the asteroid Vesta, and again, we have wonderful maps of this thing. The Dawn spacecraft orbited it for several years and sent back spectacular imagery and spectral studies of this before moving on to Ceres, where it is today, and continues to send us great maps. If you went to Titan, you would also want to visit the rings. How could anyone pass up Saturn's rings? They are vast. You could put 16 continental United States across the main ring system, okay? It's very, very big, but it's only about 3 stories deep, okay? It's a vast, vast plain of material. So imagine that we go down. This is an image of the B ring. This is something that, by the way, Matt, who did the introduction, works on. This is his expertise. At the outer edge of the B ring, you have these disturbances from the gravity of the little moons that are embedded in different places. And these things are a bit like shark fins, okay? Here they look like spikes if you look at the shadows, but this photo is very oblique. The image is oblique, so we're looking across a lot of space. And also, when you stretch a shadow out, it gets pointy, even if it's a curved object. One of the first people to notice this was Lucien Rudeau at the turn of the 19th and 20th century. He was the director of the Meudon Observatory in France, but he was also an accomplished oil painter. And he looked carefully at the mountains of the moon, and he could see on the limb that they were soft, they were curved. Long before Chesley Bonestell painted his spiky Apennine lunar mountains, Lucien Rudeau knew the truth. He knew that these mountains were curved even though they cast these long spiky shadows. So those can be a little deceptive. It turns out that on the B ring, these things are a bit like shark fins. And so imagine that we go down in our little ship and sail along and have a look at the moons and enjoy these piles of things that are waving up 2.5 times as high as Mount Everest. It's hard to imagine things on this scale, and that's what I love about the outer solar system. Everything is big, everything is weird, everything is new. There have been studies about living in these alien environments. Johnson Space Center recently did a series of studies on inflatable human habitats. The nice thing about an inflatable hab is it folds up very small. You blow it up, and so you've got a lot of living space. This one was actually designed to see if they could make it fail. They were overinflating it and cutting those little support straps, and I hear it was pretty dramatic when the thing finally blew up. Wouldn't you love to have that for a job? Just blowing up human habitats? So imagine taking this or something like it off to Titan. Now the difference is on Titan, you don't need a pressurized habitat like you do on the Moon or Mars. In fact, Titan has more air pressure than we do. So rather than wearing pressure suits, all you really need to care about is keeping yourself warm and oxygenated. In fact, Titan is an easier place to live than Mars. It's very cold. You need a good parka, but there are other problems. Every time you open the door and come in, you're tracking methane and butane and propane on your feet. And humans, sadly, really like oxygen. Just a quick question. How many people here are breathing oxygen right now? Okay, that's good. Keep that up. So you mix those two things. I mean, Titan is a nice, stable environment, right? But you bring people in, you're bringing oxygen. That's dangerous. So we'll have to be very careful. Another interesting thing is those hydrocarbon sand dunes. If you bring a spoonful in, you could probably light it with a match. Things are flammable there. Very strange. So when we go out and live there, we're going to have to keep these things in mind. People have been talking about exploring further. This Titan Mare Explorer was a great plan to float this little alien boat in the Kraken or Ligeia Mare areas on the North Pole of Titan. Ultimately, it lost out to another NASA project, InSight, which also has some great merit. But someday we would like to go back. Right now, the Northern Hemisphere is entering winter, and it will be there for a couple of decades. So we can't send anything out there for now. We missed our opportunity, our window. Although there is a big lake in the Southern Hemisphere, Ontario, that we could explore as well. But people are still studying. For example, Ralph Lorenz at Johns Hopkins Applied Physics Lab is working on a submarine, a Titan submarine. And in fact, Ralph helped me a lot with the details of my Titan submarine in my little story. It's pretty counterintuitive. You can't build a submarine for a cryogenic bath in the same way that you build one for a saltwater ocean. Some things have to be very different. So at any rate, it would be great to be able to put a submarine robotic probe there to explore not only the surface of these Great Lakes, but also underneath and even the sea floor. That may be in our future. And remember those wonderful dunes. The radar bounce from them. Their dielectric charge is very different from water, so that means that they're made of this soot that comes out. But remember too, the Titan has low gravity. In fact, it's low enough that we might be able to, if we have the right kind of wings, actually fly under human power, which would be great. That's why I would go. But in terms of landscape, these dunes would be many times as tall as the dunes that we can make here on Earth because of that low gravity. One thing that I would suggest is that the brief history we've had in astronomical exploration shows us, or at least implies, that where our probes have gone, people will follow. And so one day, hopefully, somebody will be standing out there gazing off into a beautiful Titan sunset, looking at those tall, tall dunes. And so thank you all for coming. I think we have time for questions. Do we have time for questions? Q&A? Oh, we even have a microphone.
Yes. So for those of you who have questions, please wait for me to come with the microphone because this talk is being recorded.
Are the oceans on Titan, are they optically clear? Can you see through them?
Nobody knows for sure, but some laboratory studies indicate that methane is more clear than water, so that you would see farther in. In terms of color, as an artist, am interested in that, and I've gotten several different ideas from different people who are studying it. The consensus, this minor consensus, is that it's a bit greenish, green tinted. But that's if it doesn't have any stuff suspended in it. And it's likely that it's got a lot of stuff suspended in it because this hydrocarbon snow that constantly precipitates out is very, very fine, probably like talcum powder or even finer. So that could change some things.
So because Titan is very, very cold and it has a thick atmosphere, keeping warm is a real problem, and insulation is a real problem. And how I mean, you've done a lot of research, obviously, for the book. How can we get spacesuits that aren't like super ridiculous, like don't look like the Michigan Tire Man?
Yeah, right. Well, actually, the temperatures that the astronauts dealt with on the moon were on the cold side were not much colder than what you get on Titan. There was no atmosphere, so you don't have that direct connection. But nevertheless, I think what you would have to do is set up a kind of a radiative system like they had, a mesh of fluid that continually circulates and keeps them warm. This is going to be the main power driver, probably, is just keeping stuff from freezing solid. So it's easy to pump atmosphere in a situation like that. You don't have to keep pressures up. So the main thing is going to be thermal.
I've got a question right here. Okay. There's a lot of methane and a lot of water. At the interface between a body of methane and a body of water, is there any talk of methane hydrates, which are in fact compounds that contain both of them? And it would seem to me that that would be really something that it could be a lot of it there, and the properties of methane hydrates are very different, of course, from the properties of the two individual components. Right.
So we find methane hydrates on the ocean floor here. Very, very strange structure, molecular structure on those things. Yeah, it seems to me that there are probably all kinds of amazing things happening there that we can't even guess at, but that is a very good guess because you're mixing these two things that we're familiar with here. The difference, as you mentioned, is temperature. Water there is frozen solid. It's the consistency of rock, and so it's going to interact differently with methane than the saltwater oceans do. But I think you're going to get all kinds of wondrous chemical mixes, and the astrobiology community is fascinated in Titan because it's got all the kind of building blocks of life, all this organic stuff that was probably lying around here on Earth at prebiotic times. So it's a great laboratory to study for that. Yeah.
Okay, water is denser than ice, so we don't have water volcanoes on Earth. But I was wondering about a water ammonia mixtures. Are they less or more dense than ice? Could they be volcanoes of water ammonia on Titan?
It's possible. I'm not sure about the temperature profile there, but the thing is, the geysers of Enceladus are widely thought to incorporate ammonia, which lowers the freezing point. So ammonia is all over the place in the outer system, and that's going to act as a lubricant and a game changer for a lot of things.
I don't think there's no free oxygen on Titan, so I presume if you lit a match on Titan, you wouldn't blow up the moon or anything like that.
Right.
Yeah. So you wouldn't. Nothing would light up actually.
No, it's
Okay.
in fact they're thinking of having, how we have areas of non-smoking here. They're thinking of just having the whole planet a smoking area because it's completely stable. And that's my idea, by the way. I'm very proud of that. Yes.
I assume that you have people going to the surface of Titan in your
Yes.
novel. But by the time we can get people up there, it would seem like we would probably have very high resolution telerobotics and virtual reality technology. Wouldn't we more likely send machines down that would give us very high resolution feedback?
Yeah, I'm sure we would do that first. But if Columbus had had that technology, he would have sent ROVs to the New World before he went, and he would have gone anyway. I think people will go because it's people have always been drawn to wilderness, and the planets are the highest wilderness there is. I think people will be excited enough. The question then it becomes that of resources. How do you get out there? Are the reasons good enough to go? Because it's going to be expensive. But the scenario I paint with words is that there are science outposts and small villages essentially along the equator. I think eventually that's going to happen on Mars and then beyond. I might be a little too optimistic in my timeline. We'll see.
So, Mike, on Earth, our oceans are subject to tidal forces because of the gravity of the moon. Is there any evidence that the liquid on Titan is subject to tidal forces from the gravity of Saturn?
Yes, and from other moons. Although Titan is way out there, it's not very close to any of its siblings. But Titan is tidally locked. It keeps the same face towards Saturn. So that tends to lower that, phenomenon. But it's still got a little bit of an eccentricity in its orbit. So you do get tides. In fact, there is a place that they're calling the Throat of Kraken, which they think is a tidal race, a place where the tide rushes through at one point in the cycle and then rushes back through on the other side. There are tidal races here on Earth in several places, most famously in Ireland. So it may be that you get some pretty good tidal cycles there.
So what would you use as a power source for a manned mission to Titan? Would you have to use like an RTG, or are there resources you could use locally?
Oh, great question. The place is full of hydrocarbons, so some people are talking about using that as fuel or methane, breaking it down chemically. But I think, looking at the technology we have today, I think you would have to at least initially go with a nuclear radiogenic power source. But in a couple hundred years, who knows what we'll be using. So we may even have perfected solar panels so they can work in moonlight. Who knows?
So do you think there's enough tidal force that below the surface we might get the water warm enough to turn it into the equivalent of what would be magma on Earth, and that could drive the volcanoes?
It's possible. There is not a lot of tidal friction that Titan's being subjected to. It's got a teeny bit. It's a long ways out from Saturn, and its orbit is pretty regular. You get tidal friction mostly from a gravitational tug of war between multiple bodies like other moons and the planet, or from an irregular orbit. Titan is kind of out by itself, so it's pretty stable. But it's big enough that it may have radiogenic sources inside still, keeping pockets warm. So that may be driving some of it. Bill.
Tell us about the problems you ran into when you thought about submarines on Titan.
Okay,
what's
so,
different?
Yeah, one thing is you can't, at least with our current technology, in a submarine here, you fill it up with air, and when you want to go down, you blow the air out. But on Titan, if you fill it up with the ambient air, it's mostly nitrogen and some methane, it does bad things to plumbing. It locks up all the valves. And so what we would have to do, apparently, is bring inert gas, neon or argon or something, to blow the tanks and change the buoyancy. So that was one thing. And then just being in a cryogenic bath is not a good place for mechanical things. It's just, not pretty. So there would be some challenges. But we had challenges to make the first cars, right? Henry Ford did okay. So we can do that. We can do this. All right, anything else?
Any other questions? Okay, for those of you who would like to purchase a copy of On the Shores of Titan's Farthest Sea, we have a book table out front where you may do that. Bill, do you have an announcement?
Yeah, just a little.
All right. You want to present the mug too?
All right, yeah, thank you. Michael, thank you for that wonderful talk and those visuals.
Oh, you bet, thanks.
So for those of you who haven't seen me up here before, my name is Bill Diamond, the CEO of the SETI Institute, and I think it's wonderful that we have an opportunity with Michael's talk today to celebrate an author and an artist all at the same time. And I just wanted to share with you something about the SETI Institute along those lines. People may often wonder, well, what do you guys do at the SETI Institute every day? And although if you visit our website, you'll see lots of examples of the science we do, write-ups and stories from our researchers, we have now put on the website just yesterday a report, which is basically a summary of all of the activity and the output of our scientists for the month of February. And this lists publications, speaking engagements, talks, technical reports, intellectual property filings, et cetera. I had asked Dr. Natalie Cabral, who heads up the Carl Sagan Center, where most of our scientists are parked organizationally in the Institute and do their work, to compile this information. It is our intention now to compile it on an ongoing basis. We have a rich history of scientific research and output, but most of that has been inaccessible to our typical SETI interested people. So I wanted to compile that list. It's a 9-page document. So I went to Natalie after she first presented it to me, and I said, are you sure this is just 1 month? It's not a full year of work. And she said, no, it's just 1 month. So that whole list is on site. You can get all the references to the articles published in places like Astrobiology magazine, Science, Nature, et cetera, and look at the other work that our scientists do. So I invite you to take a look at our website at SETI.org. You can download a PDF of that report and get a full compilation of what we're doing. We're also going to be using the services of a company called mysciencework.org, and they will be making available all of the published papers and documents of our scientists that are at least available on digital media. So as far back as we can go and have our articles and research papers pulled out digitally, we'll have those all available on this website. So stay tuned for information about that. There will ultimately be a link on the SETI website to a special dedicated SETI set of pages on mysciencework.com where you'll be able to explore many years' worth of research and output from the scientists of the SETI Institute. And of course, if you visit SETI.org, you have an opportunity to support our work and the colloquium that we bring you every Tuesday. So thanks very much. And Matt, thank you. And I think that we need to present the famed and priceless SETI Talks mug, but I don't see it. Oh, you've got this already. Okay, very good. So there you are, highly coveted, $1 million on eBay typically. So thanks again very much. Thank you for coming.